Hello, my fellow mathematician. Today I want us to look at the derivative of inverse trigonometric function, and we want to start with that of sine. Given y, function y is equal to sine x inverse, find derivative of y. To find derivative of y, solution, we can multiply this equation, both sides by sine y, both sides, both the left hand side and the right hand side with sine y as shown here. So sine y with y. So we multiply this equation, y is equal to sine inverse of x. We multiply both sides with the sine. So y times sine, it will be sine times sine inverse of y. Now on the right hand side, this is sine power 1. So by the law of indices, power 1 plus negative 1 is 0. So sine power 0 is equal to 1. 1 times x will give us x. So that is why here we have sine y is equal to x. Then we differentiate both the left hand side and the right hand side. And when we differentiate this side, we will get differentiating sine y with respect to x. It is implicit function. So we are going to add dy and dx. The derivative of sine y is cos y, dy and dx, because it is implicit function. On the right hand side, we get 1. Then we divide both sides by cos y. Dividing both sides by cos y, we will be left with the dy and dx, which is equal to 1 over cos 1. Then, using the trigonometric identity, we know that sine x squared plus cos x squared is equal to 1, which can be written as we can substitute. X is a dummy, so it can be substituted with any variable. So sine of y squared is equal plus cos squared y is equal to 1. Then making cos y squared the subject of the formula, we subtract sine y squared both sides, which we are going to get cos y squared is equal to 1 minus sine y squared. Now we can take square root both sides. Taking square root both sides, we are going to get, so taking square root both sides of this equation, square root of cos squared y is equal to 1 minus sine squared y. And when we do that, we are going to substitute 1 over cos y will be, that is square root of cos squared is cos y, will be substituted with 1 minus square root of 1 minus sine y squared, 1 minus sine y squared. But we know that sine y is equal to x. So dy, derivative of dy with respect to dx is equal to 1 over square root of 1 minus sine squared y, which is equal to 1 over square root of 1 minus x squared, substituting sine y with x and the squaring, we are going to get x squared. So it's equal to 1 divided by square root of that. So hence y is equal to sine x inverse. The x derivative is given by y prime is equal to 1 divided by square root of 1 minus x squared, and that is the head of this proof. Alternatively, we could have used at this level here, whereby we have dy over dx is equal to 1 over cos x, which is equal to 1 divided by 1 minus sin y squared. We can use this right-angled triangle, whereby we have 1, this x, the other side, because this is a right-angled triangle. This is a right-angled triangle. So by Pythagoras theorem, 1 squared minus x squared will give us the opposite side, which is the square root of 1 minus x. Now, we know that cosine of x from dy over dx is equal to 1 over cos x. We can consider this right-angled triangle, whereby hypotenuse is equal to 1 and this adjacent angle is x. The opposite will be 1 minus x squared from Pythagoras theorem. Now, cos y is given by adjacent divided by hypotenuse. Cos y will be equal to adjacent over hypotenuse. But we know that cos y will be equal to x. But we know that cos y is equal to x. But we know that x is equal to sin y. That is given. It is given here, whereby we found that the sin y is equal to x. Sin y is equal to x. So, x is equal to sin y. Okay, so from this triangle, from this right-angled triangle, sine of y from this right-angled triangle will be given by opposite of angle y is square root of 1 minus x over 1, this one. So substituting here, whereby we have dy is equal to dx, which is equal to 1 over cos x, and we know that cos 1 over cos y, and we know that cos y is equal to x over 1. So we substitute sin y with 1 minus square root of 1 minus x squared over 1, and we are going to get dy over dx is equal to 1 is equal to square root of 1 minus x. Hence the given y is equal to sine inverse of x derivative with respect to x will be 1 over square root of 1 minus x. So that is the end of our study today. Be keen as we continue with other studies.